Okay, guys, this is my constructive effort of teaching a lesson on video, on YouTube. Don't even know how to do that. And see if you can get something learned this week. So we're going to start with 5.6. You need to make sure you have a paper and pencil out and you're ready to write notes. And if you have to watch it 2 or 3 times to get it, that might be how you have to do it. I just talked to a student and he had a few questions. So now I kind of sort of know what your questions are going to be. So hopefully that will help you when you get this lesson. So here I go. 5.6a, related rates, brief calculus. All right. Related rates is basically you have more than one variable. You're going to derive at a time. So you're going to derive like an x variable and a y variable, just like you did in partial fractions, both at the same time, but whenever you're deriving, they always are over dt. So when you derive x, let's say you're deriving x squared, it's going to be 2x dx dt, just like in partial fractions were. Okay? So that's why in partial fractions were important. All right, so you're going to drive a variable at a time with time. You drive each of them to its variable. For example, and I just went over this, x squared will be 2x dx dt. Notice it's over dt because it's always to time. Y cubed will be 3y squared dy dt. It's whatever variable it is. That's really imperative that you understand that you drive it to the variable that it is over time. That's what it's related to, is time. All right, we're going to attempt a problem. This is not necessarily in the book because the book went straight to word problems, and I figured you'd be scared to death if I went straight to word problems today. Tomorrow, word problems. Today, we're going to do this. So, assume x and y are differentiable functions of t. Find dx dt when x equals 2, y equals 3, and dy dt equals -1. Write that down. If you're a slow note taker, you're going to have to read this more than once. Okay? So, the equation is 2y squared minus x squared minus 199 equals 0. Step 1, you're going to derive each variable. I wrote the steps down over here in different colors. I'm holding this board, so sorry if it's shaky. All right, so I derived 2y squared. I got 4y dy dt. Derive x squared. I got minus 2x dx dt. And everything else equals 0. Step 2, substitute the numbers in. So remember these numbers that I gave you in the beginning? Those you're going to substitute in. So I have 4 times 3 times -1 minus 2 times 2 dx dt, because we didn't know that one, equals 0. Then we're just going to do math. Solve for dx dt. This makes -12 minus 4 dx dt. I'm going to add 12 to both sides, and I'm going to divide by -4, and I'm going to get dx dt equals -3. All right, I have a second equation that I want you to do. I'll give you a couple more minutes, or well, seconds, and then I'll give you the second equation. Like I said, you can watch this twice if you need to. Okay, here we go. All right. Example 2. Suppose x and y are differentiable functions of t when s equals 10, dx dt equals 2, dy dt equals 4, x equals 100, and y equals 50. So write that down. Again, this is not in the book. They jump to word problems immediately. All right, my equation is going to be find ds dt if s squared equals x squared plus y squared. Remember step 1, derive. S squared is going to be 2s ds dt equals x squared dx times dx dt plus y squared dy times dy dt. Step 2, substitute the numbers you know. Now tomorrow when you're doing word problems, you'll have to figure out what those numbers are. That's going to be the hardest part. What's the rate? What's the dx dt? What's the x? What's the whatever? So I substitute those numbers in. 2 times 10 ds dt, because I don't know that one, equals 2 times 100 times 2 plus 2 times 50 times 4. And I just did math from here on out. 20 ds dt equals 400 plus 400, which is 800. That's in red. Divide by 20, ds dt equals 40. Now, if that was an area, that'd be 40 feet squared per minute. If it was a volume, it'd be 40 cubic feet per minute. So those are the kind of things that you're going to get anxiously learning tomorrow. All right, now, your assignment tonight. It's not exactly what's on the syllabus, so slow down, think twice, watch. You need to read page 398 to 401 and 403 to 404, examples 1, 2, and 4. Please read those, or else you'll be totally lost tomorrow. Totally. If you've never heard those words before I start teaching tomorrow, it'll be terrible. Then, because tomorrow is all word problems, your assignment tonight is only 4 problems. I'm going to call it 5.6a, page 404, 1357. That is different than the syllabus, so you're going to turn it in with the syllabus, though. Remember, you have to derive each variable separate. And then you have to plug in the numbers that you figure out what their variables are. There is a section called Hangout. I will try to post when I'm going to do each Hangout with every class. Unfortunately, I can't do all classes together. So I'll post when I can do Hangouts. Tomorrow I already have a meeting with the teachers online from 9 to 10, so I know it's not going to be then. It'll be after 10. Questions? Ask me tomorrow, or you can email me. I can try to answer them over email. Thanks. Have a great day. Hope you're having a good week. Stay healthy. Bye.